Thank you so much for joining us, Mr. Acharya. We also have with us Mr. Raju Goyal, who is the Chief Technical Officer at Ultratech Cements. He's worked widely in the cement industry across continents, and he specializes in decarbonization initiatives, green energy, circular economy, process productivity improvements, and energy efficiency, among other areas. Thank you so much for joining us, Mr. Goyal. We also have with us Mr. Sydney Lobo, who is an industry expert specializing in sustainability, clean energy, the power sector, and environmental management. And he's supporting various startups with technology commercialization and project development, as well as consulting on various next generation technologies and fuels. Thank you so much for joining us, Mr. Lobo. Maybe we can start with a bit of context setting for our discussions today. We know that the industry sector is one of the sort of most significant contributors to greenhouse gas emissions within the country. And this contribution can only be expected to grow as time progresses because of a variety of reasons. One being the fact that the country is yet to build most of the infrastructure it needs, to sustain economic growth, to sustain its growing population, which means that manufacturing will need to increase, and so will the industry sector's contributions. Secondly, as the power sector decarbonizes and we get closer to achieving our renewable energy ambitions, our modeling and forecasting efforts show that industry sector will actually overtake the power sector in terms of its contribution to the country's inventory. So it will become the primary contributor of emissions by the time we get to the mid-century. Right? But why is it challenging for industry to achieve faster rates of decarbonization, unlike other sectors, not just in absolute terms, but also in intensity terms? And how can progress be enhanced? And that's what we're going to discuss and speak about today. And this is a very important topic because we know that to be able to stick to the 1.5 degree pathways or 2 degree pathways, it's very important for us to transformatively decarbonize the entire economy, right, including the hard-to-abate sectors. And while the hard-to-abate sectors are many, which includes, heavy-duty transportation such as trucking and shipping and maritime, our discussion today will primarily focus on industry, particularly those industries that rely on fossil fuels either for high-temperature heat applications or as for use as feedstocks such as cement, steel, whether it's fertilizers or refineries. So maybe I'll start with Mr. Acharya. Globally, the steel sector's direct emissions are almost 28% of industry's emissions globally. So it is a majority contributor. And while emissions need to fall by almost 1/4 by 2030 to be aligned to the temperature targets, so far they've actually risen by a significant amount compared to 2010. So why is it so challenging for the steel sector to decarbonize? And how will, for example, a JSW Steel, which has set a target for itself to reduce its emission intensity by 23% by 2030, how does it plan to decarbonize and get to this target, or maybe align to net zero in the long term?
Thank you very much, Apurva, for the questions. Good evening to all the viewers. Just to put a little bit more statistics to what Apurva spoke about, 28% contribution of steel sector to the emission. Globally, it is around 7 to 9% of total emissions, direct energy-related emissions. The steel sector is contributing. And in India, it is 10 to 12% we are contributing. Whereas globally, it is responsible for around 0.7% of the GDP. In India, it is around 2% of GDP. So the emissions and contribution to GDP in this sector is not matching. That means you have a higher emissions, a lower contribution to the GDP. But at the same time, both steel and cement sector are very fundamental to economy. And specifically when India is poised to grow, and as our middle class is going to grow, the aspiration is going to grow, we need more steel, more cement, because I believe the future of India is yet to build. So in one hand, where we need to grow these steel, cement requirements, the same time, the fact is that we cannot grow the emissions. The emission has to decline. Now, what is the challenge that you foresee if energy sector is transiting to renewable energy and reducing their emission? Why this sector are not able to do that, and why it is called hard to abate? In fundamentally, Apurva, I have stated this in many forums. I personally object this terminology of hard to abate, because we need to change our mindset that we need to abate these sectors. We need to reduce the emissions. So therefore, I think first thing we should stop calling these are hard to abate, but these are difficult to reduce the emission. Why? The reason, fundamental reason, the waste, let me now talk about steel. The way steel is made, fundamentally, there are two ways to make steel. Either you melt the scrap and make the steel, and there the emission is very low, and you can really. But 75% of steel is not, 25% of steel is made from the scrap. We don't have enough scrap. We are producing globally almost 1.9 gigaton of the steel, out of which 75% is coming from the ore. And the projection by 2050 the world will require around 2 gigaton of steel. So the steel productions globally is not going to come down. And specifically in India, it's going to double by 2030 and triple by 2047. But at the same time, the majority of steel is being made from ore. So you take an iron ore, oxides of iron, remove the oxygen by putting carbon. And that fundamentally adds to carbon dioxide. So in a sense, what I'm telling, the way steel is made, it is designed to emit carbon emissions. And that is the reason why it is difficult to decarbonize. That means we have to find ways to make iron. Actually, steel making is not a problem. Iron making is the problem because iron is refined to make steel. So the iron making is the problem. So fundamentally, we have to change the way iron to be made without emitting CO2. That is one way. So therefore, those are called disruptive technology or new technology. So that means we have to find another new reducing agent instead of carbon. And the nearest candidate and nearest chemical is the hydrogen. So we can talk about how green hydrogen or hydrogen is going to be important for steel sector decarbonization. But question is, will that really decarbonize the full steel sector? That's another question. But let me bring another perspective that if you look at currently, if 70% of steel is being made from the normal terminology is called BF-BOF, blast furnace in which iron reduction happen, and BOF, basic oxygen furnace, where the oxygen purification happens. And in the electric arc furnace, you melt the scrap. These are the two ways. And majority of the steel, I told, done in primary ore to iron to steel. Now, these sectors are hugely capital intensive. That means a lot of finance is already locked in BF. Specifically, I'm talking about India or Asian countries where the maximum steel production is happening because our assets are very new. So a lot of money is locked. So I can't, dismantle them and put some new technology immediately. One is that the new technology is commercial feasibility, that we'll talk later. But this is the issue. Second thing, India has lot of iron ore availability, and incidentally, they are lower in quality, means Fe content is lower. So that means the growth has to happen again in India from iron ore to steel making. So that is going to grow in at least in the visible period, at least let us take 10 years. If you see all announcement happen to grow in the primary sector. Then question comes, how do we decarbonize? So to decarbonize, we have to think differently. First, we need to think what we can do with the existing assets. The existing asset, the primary asset where fundamental reduction is happening. That is only possible by increasing your efficiency. So when I tell increasing efficiency, you have to use energy efficiency in everywhere. There are best available technology known as coke dry quenching, top recovery turbine in the blast furnaces. So there are many technical terms, waste heat recovery boilers. So try to use as much heat energy which is going waste as possible. So you become efficient. So that means you produce more with less. Second part, improve your raw material efficiency. I told India ore quality is little poor. That means you put more carbon. So that the other way, if I have to reduce my carbon, I have to improve the ore quality. So that is called a beneficiation process. So that we need to do more and more so that we use less coke. And anyway, India is importing coke. So our import bill can also be reduced. So that is another way. Third way to reduce, because I'm talking about the existing asset, is that energy transition which is happening. Anyway, the electrical energy is becoming cheaper and cleaner by using renewable energy. So we need to transmit to renewable energy as possible, but there is a challenge. because iron industry, like cement industry, are run 24 hours a day and 7 days a week and 365 days a year. It has to continuously run. So you need a round the clock energy supply. Right now, that is the challenge, because renewable energy has its intermittence. But I hope we will went through that. So these are some of the things which right now we can do, and we must do, and we are doing. Next comes what we need to plan ahead. If India has to triple its capacity by 2050 or double its capacity by 2030, I think we can't do anything much because already the plan is made. But I'm looking beyond 2030. That is where we need to look at the disruptive technology. That the technology which will change fundamentally the way iron is made. That is where green hydrogen will play an important role, provided or when it becomes commercially feasible. But will green hydrogen solve all problems? No, because we need a combination of technologies, but that is going to be one of the major lever to reduce going forward. Second is that I told, because you are not going to reduce iron ore by DRI all your requirement of say 500 million ton cap in India or 2 gigaton for the world. So therefore, the scrap availability has to more, and iron and steel on an average takes 40 years to become scrap. And in India, we are growing. Our consumption is still lower. We are around 75, 76 kg consumption, where world average is around 250 to 225 kg. So that means a lot of iron and steel is going to be consumed, and then it will take 40 years to come back. So that means, our scrap availability is going to be a challenge from now, in the growth phase. So therefore, but at the same time, we must leverage that. We have a scrap policy, so I hope it will work, and so more and more scrap will be available. The third one, which is that the residual carbon, which anyway you have to make from the feedstock what you use, you have to capture and bury it somewhere, and that's known as CCS. Possibly will transit from CCU to CCS. Now, to address your last question, that what JSW is doing as a leading steel maker for the country, I think our strategy is no different than what I stated to you. So we are working on what we can do in existing assets and what we need to plan going forward. So exactly same way, our aim is to phase out thermal coal by 2030, to increase the scrap availability by 10%, by increase the beneficiations, reduce the non-carbon based reductant as much as possible in the blast furnace, for example, biomass, hydrogen, green hydrogen injections, natural gas, which is lower carbon than the coke. So we go on doing that. So this is the plan, and that is where we are thinking that we'll be able to achieve our 2030 target to reduce 42% of our emission from 2005 baseline. Right, but going forward, it has to. But one more thing you need to note, Apurva, while we are working to reduce our intensity in the shorter term, our challenge will be to reduce the absolute emissions in the mid and longer terms. Because even if we are reducing our intensity as the Indian steel industry, our absolute emission is going to increase in the short term, which I agree with your comment, and that with the fact that the rest of the sector has to really supplement the difficult sectors like cement and steel. Let me stop here, and I'll discuss any other question. Thank you.
Yeah, no, those are great points. And like you mentioned, we fundamentally need to change how to make steel to be able to decarbonize beyond an extent or get to net zero. There's a structural shift that's needed in technology, given that the majority of the steel today is made from the BF route or even the DRI route, which is essentially dependent on coal. Which means deep decarbonization actually means upgrading or replacing assets and infrastructure, right? Which is a critical challenge. And I think it's a similar challenge for the cement sector as well. So maybe I'll also turn to Mr. Goel. We know that the cement industry is one of the most emissions intensive sectors, even when we compare to the other energy intensive sectors. For example, cement actually generates more than 4 times the GHGs per unit revenue than even steel does. But the challenge is very similar in terms of what Mr. Acharya said, in terms of the structural shifts that we need. So if you look at emissions, process and fuel related emissions account for a significant proportion of the total emissions in cement. similar to what what the case is in steel. So both process modifications and energy switching, efficiency, all of this becomes important from the deep decarbonization aspect. So what are some of the specific challenges for the cement sector from that perspective, and where are the gaps?
Apurva, thank you very much for this question. I think very much related to the what Mr. Pamoda has said before. So let's put it in the perspective of that. I think we can say that 7% approximately is the CO2 globally produced by the cement industry. And take the in Indian context is about roughly about 6% of the total CO2 in terms of that. And as you know, the cement industry is growing very fast, and the predictions are there. By 2030, we'll be in the range of the 700 million tons production will be there from the current level of about 400 million tons. So yes, there's a big challenge. By the time we are going to expand our capacity and things, same time we have the pressure to reduce our CO2 footprint also. And just you mentioned that, let me put some numbers on that one, what he said, because in the cement industry, we divide our whole footprint of the CO2 in the 3 scopes, what you call. So scope 1, scope 2, and scope 3. So let's discuss about scope 1 and 2 today, because scope 3 is still, we have to see that how this is going to be counted and will be built around that, ecosystem will be built around that. So in scope 1, about 60% to 65% CO2 is coming from the calcination of the limestone. And that is our prime. I will not be shy to say that this is really, really hard to abate, because there is no other material which can fulfill the requirement and fulfill the chemistry of the limestone, what is available right now. Then about 25 to 30% is coming about from the fuel which we use to burn our process. In that, so currently in the limestone side, there's the very limited work or limited things are happening. So I'll come back to that secondary, but let's talk about the which we are working currently and which is happening right now. So in the fuel substitution, if you see that compared to the other countries and things, India is still a bit lagging in there, but a lot of work has been done to expedite that usage of the alternative fuels and alternative energies in that area. So alternative fuels, one of the area which we are trying to replace the traditional and conventional fuels, which is like a petcoke, coal, and the things are there. And then second, we talk about the energy consumption, because as similar to the steel, I think in cement industry also very energy intensive process. We need a lot of power, lot of thermal and electrical energy is required. So electrical energy, which we are doing, like, because we have the waste generated from our process, which is called the waste heat, which have certain value of that. So we are putting up waste heat recovery systems to find the power generation and feedback to the process. Dependency on the grid as well as the CPP will be reduced, which means we can have the significant reduce our carbon footprint into that area. So this one area is working on that. Alternative fuels are there on the thermal side. Let's talk about this, what is happening on the limestone reduction, which is the very hard, I will say, that to reduce, because calcination will need to happen then. Otherwise, the property of the cement and quality of the cement may not be possible in that area. So what we are looking for, that we are looking at the product size of that. So we can minimize the clinker content into the process. If I can say, the put up a perspective in that, like if you say that India is the one country in the world which have plus 70% blended cement in the market compared to the rest of the country. So blended cement and things, product developments are happening significantly, which is supported by all the waste generated by the other industry also, like steel, power plants, and other mineral processing, which can be substitute as a alternative for our clinker and the other additive materials to reduce our footprint on that side. So let's so these are the things which already happening in that. I think we are much advanced. Again, I will say that substitution the alternative fuels will be the one of the steps which we are going to do it very significantly. Industry is working towards that. But coming back to all the CO2 coming out from the limestone. So what are the possibilities are there in cement industry? Currently, we are talking about the CCUS, because capturing fast, because capturing can be done. That is the only one lever which we see that is going to be, if I can put the number on that. So like this contribute the significant in our roadmap, how much CO2 can be reduced is about 35 to 36% CO2 can be reduced by capturing of the CO2 in our process. That is one of the biggest lever we see that. And now what is the challenge what we feel in that area? I think the capturing technologies are quite mature and quite economically coming down, more like in approachable range, but still not in the business sense kind of a thing still there. But still, road is getting this. We are very close to get this economical solution for the capturing. The biggest problem what we feel what is happening now after capturing, what is the utilization? That link is still missing that one. Even though you can capture with the certain pain or certain the cost and things, but what do you do after capturing that? So this link is still building up. A lot of startups, a lot of innovations are happening that side, but the commercialization as well as the pilot or industrial scale has not been proven right now here. So there's the biggest challenge on that side there in the process. And coming back to the hydrogen, so when I say the like a scope 2 and scope 3, I think in this place the hydrogen can play the very important role in terms of either the vehicle or transportation or the power generation or other methods. But per se in the cement manufacturing, still I think is a long way to go to use the hydrogen because the process requirements are very, very different. And then I think EV is the one of the area which look in the, because the cement industry is not the manufacturing of the manufacture the cement, but cement companies are the biggest logistic companies also, because they are using the up and down lot of transportation is required in that. So it means the EV can also play the very important role to to scope 2 and scope 3 reduction of the CO2 on that side. That is one of the lever which you are working, and I think number of things have been seen in the market happening. Especially, I can say the number of the companies are talking about the in the mining area. They have the battery-owned heavy earth equipment which is consumed lot of diesels and lot of petrols and things. So things are start moving up. So coming up the scale up is I think is required. That's I think one thing is required in this scale up. I think that's the industry. I will say that like a I will not call the problem, but it's a challenge, because how to adopt this scale up of these technologies with the business as usual. There is some kind of a either the incentives or either the support of the government and things, or policy interventions will be required where these things can be make it as business as usual, because this is not in our core area or core business models are there. So these are things are happening into that our space. A lot of things working on that. A lot of pilots are happening. A lot of the innovations taking place, especially in the cement. And coming back to the, I want to draw the one of the more which very close to my sense, that the product development, because in the cement the product development will definitely make a big leeway to arrange or make the our CO2 footprint in reduction of the CO2 manufacturing as well as the cement portfolio. As we all know that like a concrete is the second largest commodity used after the water, right? So because we need a cement in that. So type of the concrete production and type of the things will be definitely the diversification that will help us. As we know that precast and the 3D printing is taking place very significantly in that space, and that is going to help industry in overall footprint reduction. And I think this is also one thing we have to see that right now industry is only talking about the CO2 footprint on the per ton of cement. And I personally believe that is not the right indicator. We should look into the concrete point of, because the end product is a concrete. So how this will be seen as a concrete footprint of what, because cement is only the intermediate product. Second, what I also believe that based on the past experience in the different countries and things, in India, although there are the 16 type of the standards are available in India, but 95% production is only what the 3 standards are using in that one. So other where the low clinker and low CO2 products can be produced is not still in the market. What I'm trying to say with that, because one bag a person purchase, he used for the foundation, he uses for the plastering, he uses the brickwork, he uses the roof, he uses for every applications. Do we need that kind of a thing? So application based and things can be definitely change the product portfolio, and product portfolio will definitely drive the industry decarbonization in the whole process there. And definitely the innovation is going to be happen by significantly into the how to use that captured CO2, because that is the one of the area which we are working on.
I think you made some, very important points, and I agree that it's a, common misconception that, switching electricity sources can make a deep dent for industry, but it's actually the process heat that contributes to more than 2/3 of emissions, and that's the hard bit. But like you highlighted specifically for cement, beyond decarbonizing heat, process emissions are a major challenge because they're also a majority contributor. So if you look at ways to decarbonize, there's a technical limit to which substitution of clinker can happen before it impacts, performance. Or like you said, CCUS then becomes an indispensable sort of lever. So having said that, maybe I'll turn my attention to Mr. Lobo to maybe talk through some of these futuristic technologies a little bit more. We know that in India, a lot has been focused on energy efficiency or enhancing the share of renewables, and we've actually made considerable progress on both fronts. But with sectors like steel and cement, like you mentioned, deep decarbonization in the long term has to be enabled by hydrogen or CCUS, right? Whether it's cement or, for example, in steel, Mr. Acharya highlighted that there's a limit to which energy efficiency improvements can be made or how much scrap can be made available, given how much we're generating and how much we need to grow. So given this, the fact that we need CCUS and hydrogen in the future, by when do you think such technologies can come to parity with the traditional technologies, for example, green hydrogen coming to parity with brown hydrogen? And how can perhaps industry be incentivized to adopt technologies like CCS, even as we're finding ways and means to store that CCS? In India, there's more to focus on utilizing that carbon rather than storing it. But even in that sense, if you could also come in on CCS to maybe talk about how that could be made or incentivized or made more profitable, because eventually, the profitability of CCUS, it really depends on how you can use that carbon. And at present, there are very limited ways in which it's being used, either for enhanced oil recovery or for example, use in specific products or for the use of methanol, which is still nascent. So, where do you think, what do you think the sort of forecast is for these technologies, and how can we help sort of incentivize and increase their adoption?
Thanks, Apurva. And good evening to all the viewers and my co-panelists as well. I'm sorry to start on a pessimistic note, but I just read a few days ago that a group of scientists have said that we've got only 10 years to actually do something. Otherwise, within a century, because of all the natural calamities, power can get extinct. So, we need to work really fast. But let me just start from a very high level. Today, the government has said that, okay, we'll do a lot of hydrogen and things like that. We'll set up Ministry of Power and issued a policy saying that we'll generate hydrogen hubs and things like that. But at the end of the day, who's going to use it? Where is, you put a power plant without a power purchase agreement is never heard of. Okay. So the thing what is required first at the government level is declare openly to the entire world what is your plan. Okay. Just don't say that okay, we'll make a hell of a lot of hydrogen. Talk about carbon capture, talk about utilization, talk about the downstream space. Now heavy industry, as Raju mentioned, vehicles which run in the mines. If they run on battery, they'll hardly be able to lift the amount of material that they are lifting today because the battery is such a dead load. So you need maybe hydrogen-based fuel cell vehicles, especially in the heavy automotive space. Long range, they can carry whatever they are carrying today. So those kind of things. And that plan is very important to put in place and give a tentative time frame. Or let the government say a tentative time frame. I'm just taking an example. By 2030, all heavy vehicles will run on fuel cells and hydrogen will be the fuel source. Now, that also gives an impetus to those who are working on the hydrogen space and the automotive space that, okay, we have to work on something and by 2030, there is a market for it. And obviously, everybody looks at the cost. We are talking about hard to abate. Hard to abate, why are we saying hard? Because we are referring it to what is the cost of 1 ton of steel today or what is the cost of 1 bag of cement today. And we want to maintain all the abatement within that same cost. Okay, we can abate, but the cost of the steel and cement will just go skyrocket. So the high level plan is something which I don't see. And once that high level plan is made, industrial sectors can dovetail their plans into that. Then it will be clear who's going to use what. You mentioned about carbon capture. And as Raju said, yes, carbon capture, we capture the carbon and then do what? If you store it, it's a cost center. Nobody is going to pay you for it. And it's a burden on the industry. But carbon can be captured technologies are quite up to date commercial, then you utilize the carbon. Captured carbon can be utilized for many other things. I mean, if we are successful in making economical hydrogen, forget about the color. The color is something which is just given based on the way it is made. But you can blend that carbon dioxide and hydrogen to make methanol. Catalytically, it can be done, and it is done. Now, let's say we can do that. Then where will that methanol get used? So that's what I'm talking about, is the high-level picture. Can that methanol be utilized in blending with gasoline to run in an IC engine vehicle? Now, if that is to be done, then there has to be that big picture so that the automotive industry can work and innovate in the engine space, because methanol is very corrosive. So that's what I'm talking about. Even in terms of capturing CO2, yes, you have to have a big menu to utilize that CO2. You can utilize it even in greenhouses in order to increase food production. But of course, how much will you utilize? Okay, you can't utilize all of it. So there has to be different solutions. And each industry or each sector will have to put their plan in place, that this is what I'm going to do, this is the money that I require, this is my time span. And at the end of the day, I admit, and I can openly say that nobody will be able to say that I will be able to abate 100% of my carbon emissions by, technology. So at the end of the day, there has to be initiation of starting up your carbon sinks, because, okay, we've got decent amount of land. Build up those sinks, because the sink takes time in order to absorb that carbon. And that can be a public-private partnership, wherein private industry and the society at large build up your sinks. Those sinks could also somehow, start giving you fuel in the form of biomass-based pellets. So that's where, we were talking, that's where some kind of circularity also comes in. So, you can do that as well. Of course, there are other spaces where the carbon can be utilized in terms of, in the beverage industry or making dry ice, even to a very small extent in fire extinguishers. There are different modes wherein, but again, as I said, you can't utilize 100% of the captured CO2. The largest consumer or the largest utilization could be in making methanol, for which you need obviously economical hydrogen. And hydrogen, yes, there are technologies or startups who are working in the space of making very economical hydrogen. And of course, they just need to kind of deploy it or whatever, so that they can demonstrate it and say that it is at this cost. Hydrogen can be made, but then hydrogen has got a very low volumetric density, but very high gravimetric density. It's a high energy content fuel, but it also has its own issues. There's something called as hydrogen brittlement. Now, whether hydrogen is used in the iron industry, okay, they can use it in the DRI process, but transporting it, storing it, all these issues have to be looked at simultaneously by different agencies together. For example, suddenly, if you're talking about storing tons of hydrogen, then you'll have your chief controller of explosives coming in and saying, you need to do this, you need to do that, and all that. And then, it kind of puts a setback on things when you do it, one hurdle at a time. If we all work together in a collaborative manner, then things will move much faster. This is my point of view, that we need to have that big umbrella picture, and then you have to have the smaller umbrella sector specific, which will dovetail into that. And everybody has to work simultaneously. We cannot say that, okay, once Apurva finishes, then Prabodha will do, then Raju will do, then Sydney will do. No, it's not going to work that way, because by that time, so I rest at that place.
Yeah, I think it's interesting you touched upon partnerships, which was one of the sort of major themes within COP27 also this time, within progress that was made within the breakthrough agenda. where steel, cement, hydrogen, all of these are very important themes where countries are collaborating at this point. But you also touched upon the cost of product, who's willing to absorb that additional cost. And this has been another very important theme in terms of finance, right? Which is a very common challenge between countries and companies that was talked about throughout, the 14 days of COP. One common issue that was raised across by countries in their opening remarks, but also in the discussions in the 2 weeks that we were there, was that the cost of capital is at such odds with the potential for decarbonization across countries. And that's a major challenge. While a lot of investment is being made in developing countries that have the largest potential to decarbonize aren't necessarily sort of receiving that support that they need. So in terms of finance, how do we rally investment or accelerate capital deployment to fund this net zero transition? And what is the kind of support that industry needs? This could be a common question to Mr. Acharya or Mr. Goel as well, whoever would like to answer it. But what are the specific finance needs within whether it's the cement sector or the steel sector that can actually enable deep decarbonization in the long term?
Well, let me start off. When we say finance, okay, or we talk about the startups who work in this space. Today, they are working based on a certain USP in their technology. Okay, it's only when they go to the industry or when they go out, they realize that their product is too expensive and it doesn't make techno-economic sense. I would say that the industry should challenge the startups and say that, see, I need hydrogen at this cost, at this or this levelized cost of hydrogen, and this is the volume I need. Who can make it for me? So when you give those thresholds that this is what I need, what the industry needs, automatically the startups have been given a goal. Okay, and if that goal has been given in startups, or I'm just talking about startups, even big industries, if they can work towards meeting that requirement, then it is automatically a viable project, because whoever is asking for that much amount of hydrogen or certain material at a certain cost, it is making sense for him. So it becomes just a viable project, So the concept of then giving some SOPs or whatever, or specific green finance for that just doesn't arise because it has got techno-economic viability. Now coming to the part of finance, where in certain areas, yes, there is always a challenge. You may be slightly a rupee or two more expensive than what it is. But I mean, that I think one has to work with your government or with the financial institutions that, okay, are you willing to give loans or are you willing to disperse funds, say 1% lower than the others? And also industries have to take a call saying that, okay, for these kind of projects, we want it to be economically viable. Am I willing to take 1% hit on my IRR? Am I willing to do that? It's yeah, I mean, shareholders might say, y'all are nuts about it. But remember that this is not a someone's P&L statement that one is looking at. This is a global issue. If I may just use the example of COVID, how the entire world rallied together to fight against that virus. This is a different virus, but you can't see it, or you can't see it under the microscope, and you can't see that it's going to take your life in the next few days or whatever, because this is slow killing. But that rallying has to happen, and funds will come. I mean, when the time is, if it's a techno-economically viable project, there's no need to look at green financing, things like that.
It's interesting you mentioned that in terms of the pricing of products, and I remember Mr. Acharya speaking to you about this at the COP, and you mentioned the word greenium and the fact that a greenium has to develop. This has also been a focus within the breakthrough agenda that I mentioned, right? Like, how do we enable public and private procurement to drive up that demand for green products specifically? Once you develop that sort of taxonomy of what green really means. So I know that you have been a proponent of that concept for very long. So I don't know if you want to reflect on that.
I mean, let me first give a comment on the financing. The fact is that financing is sufficiently available. It is not that financing is not available. Question is that the financing for this project, which Sydney talked about, which are not viable at the moment. And that is where the importance of greenium comes, or green premium comes. Let me explain what I mean. Look, 30 years before, when I started my career, the same things were talked about, the solar power. So, and now the penetration of renewable, you all know, the story all you know. Same thing we are facing with CCUS, we are facing with green hydrogen or any project. So when I tell finance is available, let me give example. Last year, JSW Group, we raised almost $2 billion of various finances through sustainability linked bond or green bonds. So these are available, right? Now, of course, you can ask me, why don't you then put up a green hydrogen project and take $2 billion of dollar? The question is, that comes to Sydney was talking about. Right now, that project itself is not viable. So to make it viable, you need additional premium or greenium or green premium, right? Which gradually over the time will be zero. It has to be zero. But initially, you require that inertia. Now, question is that who will put that extra money, or where from we should get? And that you see what is happening in Europe, what's happening in US. All these so-called breakthrough technologies are being funded by public money to take on that extra greenium, green premium. Of course, it is towards the product. I'm talking about the project. So that is required, and that is required in India itself. Now, what is the societal cost? And that is where the green premium has to come. But then who will do that? Do we have a mechanism? What will be the role of the industry and role of the government? I sincerely believe creating a demand has to be initially done through policy intervention. And that is where the taxonomy plays a very important role. The first step is to define what green product is. Second, you create a demand mandatorily for the initial period. You know Newton's law, right? To everything, every inertia requires a force. So that will act as a force. Same thing, you look back on the renewable energy sector. The mandatory obligations or RPOs keeps on increasing. So why you cannot have a mandatory obligation of green steel, green cement in the construction sectors, in the infrastructures? And that initially will create that demand so that the industry will try or inclined towards producing those products. Now, when they start producing this product, the new so-called breakthrough technology even will not be sufficient to take care of the green premium which you might command from the customers. And that is where you need additional support, or the government, public support, or whatever way, some kind of support to make it initially happen. Because once it starts rolling, now once the demand is created, now once the enough supply is available, you have perfect balance of push and pull. It will run, and gradually over a period, if you are looking at 2050, I would expect the green premium of the product should be zero. The cost of production should take care of the cost of sales, or the product cost. And that is how it has to work. I am very optimistic about the progress of technologies. I also believe that technology penetrates in an exponential rate. We have seen enough examples, whether it is the renewable sector, whether it is the IT sector, whether the chip manufacturing. So I'm also absolutely sure that the uptake for this breakthrough technology will also exponentially increase. So therefore, we need to be optimistic and keep supporting industry to break that initial inertia. And that is either through public support or through product support.
It's interesting. You mentioned the policy push, and I agree that the policy push has been a major driver across green sectors in India. Whether you talk about solar or electrification, or you talk about energy efficiency to an extent, because energy efficiency is also provides you some profit in return. But at least for several other sectors, it's been a major push. But what about partnerships within industry? Can we exploit sort of existing synergies across industry sectors in terms of energy or finance or circular economy. Mr. Lobo just had touched upon that. For example, maybe the next question can just direct at Mr. Goel. The cement industry has been working on the circular economy space for quite some time. But are we doing enough in terms of enabling industrial symbiosis? And if not, what more can be done? We know that synergies today can be exploited even within cement and steel. For that matter, even with power or fertilizers or textiles within the cement industry. So, for example, if you talk about cement and steel, the blast furnace slag can be used for blending or blast furnace slag cement. While it may have its own issues with strengths, there are various characteristics that are premium in terms of durability. Or, for example, the gypsum from FGDs in thermal power plants can be used to substitute natural gypsum within cement. With the new regulations that are going to be implemented for air pollution norms, we may have a lot more availability of that, right? So in terms of these synergies, have we been efficient in perhaps harnessing these synergies, and what more can we do?
Thanks, Apurva. I think previous both co-panelists has touched very important points on that. And coming back to your question on that, I think in cement industry, a lot of circular economy is happening. A lot of things are happening. And coming back to the breakthrough technology things, which is not yet in the platform, I really buy the concept what Mr. Sidney has mentioned, that I think we need an ecosystem. Is not you solve my problem, then I'll talk to you. It's not like that. There is a problem statement. We have the problem and work together to find the solution. Either we tell the problem statement, then find the solution together, or it's not like that. This is the problem, find the solution, come back to me, then I will look into that. This may not be enough to do it. And this is why personal thought, it may not be, I will not repeat again this one. I'm still believing that this why we call circular economy. Because when this word comes the economy, then everything becomes very, very, because everybody want to see the win-win in that situation. Why don't you call the circular responsibility? Because that might change the whole stakeholders game, and where everybody has to play their part in that. Because economy word becomes, again, as I mentioned, that why we say the hard, I think very rightly said by Mr. Sidney, why we call this hard to abate. It's hard to abate is not because technology is not available, because it's not commercially viable. So things are coming back. If you come back and work together as a whole ecosystem and work together in that, which might solve a lot of problems. And I think one point Wisdom Pravada has said that scale of economy, because in our business, scale of economy, I will give the one example of that. When about 6 years back, when I started working the first megawatt of the solar panel, it was in the range of the almost 10 crores, 1 megawatt, right? And I'm sure that you know what the price of this today, because when the policy interventions comes, because 2016, 2017, this policy intervention came, and then whole industry got ready for that, and the demand supplies increase, and the whole economics of the scale was completely changed. And I will not be wrong by saying that now is the 1/4 or 1/3 of the cost of the solar 1 megawatt right now. So this is, I think, if the policy interventions, industry work together, as well as bring the solution to the problem, and scale will be increased. When demand will increase, I think cost and things will be automatically, I think, coming back to our whole what you call in our reach. And second thing also, what I feel like one of the I see the difference is because industries landscape is very diversified. Some industries are very mature, some are the very not that mature, some are the large, some are not that large. So there's the scale of that industry landscape. So somewhere we have to take this partnership and somewhere bring all the companies together and say some kind of a like either the consortium, like a GCC is one consortium, right? So some kind of a things we can work together and say that what can be done together. Because if I have to do the one pilot, for example, I have to do the one pilot alone, I cannot afford it, to be honest with you. Right? If 5 or 6 people join this hand and do the one pilot and test the technology and test the concept or POC kind of a thing, it might be work, and then everybody can get the benefit of that. So somewhere the ecosystem and some kind of a consortium and work together to find the solution might work. Not like that, I find a solution, then I come to the table to discuss with you. We may not be solve the problem that fast as we are discussing it. That's what my personal thoughts on that.
Yeah. So, Apurva, just to add to what Raju was saying, in the cement industry, I mean, yes, there is synergy between steel and cement. or even between a thermal power plant and cement.
Fly ash, yes.
Fly ash. You can blend. The regulation says that you can blend up to 25% of fly ash to make pozzolanic cement from ordinary Portland cement. Now, there are technologies available where you can chemically and physically activate the fly ash and take it up to 6%. You can blend up to 60% of that chemically and physically activated fly ash with OPC to make PPC. But the regulation doesn't allow you to do that. And you get the same strength. I mean, you will get the same M50 strength concrete, be it an OPC or whatever. So somewhere there has to be this flexibility as well. Don't tie the industry, you tie their hands and legs, with regulation, and then you throw them into the pool and say, now do freestyle swimming. Not possible. You have to kind of give them a little bit of, liberty in order to kind of go beyond, as long as you're not sacrificing the end product. And I think Raju mentioned a very valid point. Do we need to use OPC for everything? If you're just doing a PCC on the ground, just plain cement concrete on the ground, you don't need to use OPC. You can use PPC, or you can have a different grade of cement as well. So I think regulations also play an important role, and they have to be nimble enough to change quickly. It shouldn't take donkeys years to change those regulations. Otherwise, we'll be, even next year we'll be speaking on the same subject and nothing will have changed.
Yeah. Can I add one point on Mr. Sidney's point on that, just to allow me 1 second also? And Mr. Sidney rightly very well point mentioned that why do we need a specification of the cement when the final product is a concrete? If I can produce the concrete durability, workability, and the strength and things, and by different means of that, because right now the chemical industry has changed significantly. Mr. Prabodha will confirm that, because chemical industry, admixture industry has tremendously innovation happened quite significantly. Are we taking the advantage of that? So this kind of things would look into that, where we should play our game. Are we playing the game into only this pocket, or we are playing the wider place? So this look into the whole industry, construction industry as per se, not only the cement industry alone.
Interesting. So my takeaway from this.
Point here?
Yeah, sorry. Go ahead.
Can I add a point here?
Yeah. Yes,
please.
I really liked Raju circular responsibility instead of circular economy. But let me tell you, the steel industry and cement industry are real champions of circular responsibility or circular economy.
Fantastic.
Let me give example. All my blast furnace slag are used for cement industry. In fact, in JSW, we have a cement business you might be knowing. Yeah. It is only developed to use the slags, and it's an excellent example of making a business case out of circular responsibility or circular economy. All the gases which is coming from the steel industry goes for power generation. All the dust which is coming from the steel industry goes again back to sintering processes, right? So only challenge, and that is where Mr. Lobo is absolutely right. We need to see in a holistic level on its application. I think Raju also talked about, and I will give another example. We have a challenge that what we'll do with the steel slag, not the blast furnace slag, the steel making slags, which are heavier in nature. And now we are working with the government to prove that it is an excellent replacement of the aggregates, which is naturally you are destroying the places. And this can be used. And we are very close to get it approved and be a part of the legal systems. So now it is a dichotomy whether regulation should come first or industry should encourage to have. I think we have joint responsibility. We all need to work together, regulators, industries, academia, and that's what I think Mr. Lobo talked in the beginning. The entire collaboration is needed to think through. And then both industry need to work with Raju. You talked about, I give another example. We are doing carbon capture and utilization. So one of the things right now we are discussing, can we use the captured carbon from steel industry to be used in the concrete process to reduce the demand of cement? And you gave some example which exactly in technical term called material efficiency, both cement sector and steel sector. And this is estimate by IEA that 33% of almost 1/3 of emission can really be reduced by bringing in material efficiency. That means using less material to get the same intended results. So that's anyway is happening. So you got the example that how circularity is working and what we need to work together. I think we need to work again. I told we all need to work together, specifically regulators, academia, standard setting bodies, and industry together to find opportunity where we can work together and change the way we do things in a better way.
Of course.
Great. And I think my key takeaway from this is that, policy doesn't just need to be a driver. It needs to not be a roadblock as well. And perhaps a little bit more autonomy to industry in the way that you innovate. But above all, I think the spirit of collaboration is something that needs to be fostered, is from what I, hear from you. We're almost out of time. I was told that I have a hard stop at 6:30. But this has been a super informative discussion for me. Lots of takeaways. So thank you all, for all of your inputs, and thank you for joining us. Thank you.
Well, thank you, Rancha, Purva, Pramoda, and Sydney sir. It is a pleasure to talk to you on this platform. Thank you.
Thank you. Bye-bye. Good night.
Bye.